The AI landscape just experienced a major shakeup, and it's not from OpenAI or Google. A small Singapore-based company has introduced an AI system called HRM that's redefining what we thought possible in machine reasoning. This isn't about scale or massive datasets, it's about fundamentally different design principles. Somehow, this neurologically inspired system is outperforming competitors that are 4 times larger. Traditional models like ChatGPT follow linear problem-solving approaches. When one step goes wrong, the entire solution crumbles. HRM operates differently, using cyclical thinking patterns similar to human cognition, and the outcomes are remarkable. This isn't just another downsized language model or simplified transformer. HRM represents a genuine paradigm shift. It replicates the brain's hierarchical decision-making processes and applies them to artificial reasoning. This innovative structure allows a compact 27 million parameter system to surpass models containing hundreds of millions or billions of parameters. For perspective, the original GPT contained 117 million parameters. HRM uses 27 million, roughly 1/4 the size. Yet it consistently beats Claude 3.5 and OpenAI's o1 Mini across reasoning evaluations. Current AI systems depend on sequential reasoning chains. However, any error in this sequence can derail the entire process. HRM abandons this fragile approach entirely. The architecture features 2 interconnected components, a strategic coordinator and an execution engine. The coordinator functions as deliberate, big-picture thinking, while the execution engine handles rapid task completion. Imagine a general developing battle plans while lieutenants carry out orders immediately. These components communicate continuously. The strategic layer formulates approaches. The execution layer implements them and reports results. Then the strategic layer adjusts accordingly. This iterative process continues until reaching optimal solutions. The performance metrics are extraordinary. On ArcAGI evaluations, essentially intelligence tests for machines, HRM achieved 40.3% accuracy. This surpasses Claude 3.5 feet seconds, 21.2%, and OpenAI's o1 Mini at 34.5%. A single GPU system is defeating industry giants in pure reasoning capability. During Sudoku challenges at expert difficulty levels, HRM solved 55% successfully. Competing systems from major companies, complete failure, 0% success rate. In complex maze navigation through 30 by 30 grids, HRM found optimal solutions 74.5% of the time. Again, competitors achieved 0 success. These results came from training on merely 1,000 examples per task type. No enormous internet crawls, no extended pre-training phases. According to researcher Guan Wang, you could develop expert-level Sudoku capabilities in just 2 GPU hours. The efficiency is unprecedented. Beyond impressive benchmarks, HRM addresses fundamental limitations in current transformer architectures. Standard language models allocate identical computational resources regardless of problem complexity. They can't recognize when situations require deeper analysis or additional processing time. HRM's dual-layer design dynamically adjusts reasoning intensity based on task difficulty. Advanced versions use reinforcement learning to self-determine optimal iteration counts. Straightforward problems receive minimal processing cycles, while complex challenges get extended analysis. This mirrors authentic adaptive thinking. Lower memory requirements enable multiple concurrent models or accelerated training with reduced hardware. HRM can operate on standard laptops or integrate into mobile devices and robotics. The company is already piloting healthcare applications for rare disease identification and weather prediction systems, reportedly achieving 97% accuracy. The development team includes veterans from DeepMind, Anthropic, DeepSeek, and xAI industry leaders who've migrated to this brain-inspired approach after working on cutting-edge projects. Wang boldly stated, "True artificial general intelligence means human-level capabilities and beyond. Sequential prompting methods are temporary workarounds. We've created genuine thinking machines." Such confidence typically signals marketing hype, but the evidence supports these claims. The complete codebase is publicly available on GitHub. Anyone can download, modify, and experiment with their own implementations. Admittedly, current capabilities remain specialized. HRM excels at reasoning but won't compose poetry or process emails. However, as conceptual validation, it's among the most compelling demonstrations we've witnessed. HRM stands apart because it's demonstrably functional, consistently defeating quadruple-sized models using minimal training data without pre-training requirements. This transcends theoretical possibilities. Barring massive investments in entirely new foundation models, the next major AI advancement likely won't be another enlarged GPT variant. Instead, we'll see novel architectures delivering superior reasoning, efficient training, and affordable deployment without requiring data center-scale hardware. If HRM's trajectory continues, it could herald AI agents residing in personal devices rather than remote servers. These systems won't merely search databases, they'll engage in genuine reasoning processes. What's your perspective? Could this represent AGI's future direction? Share your thoughts below in the comments. Subscribe and hit like for more cutting-edge AI coverage. Until next time.